Welcome to The Explainer. Today, we're going to pull back the curtain on something you use every single day, probably without even thinking about it. We're talking about how every app, every website stores its information. This is the invisible backbone that stops our digital lives from just falling into total chaos.
I mean, really think about it for a second. How does an online store remember what's in your shopping cart, or your login, or that social media app that somehow knows every single photo you've ever liked? You know, if there wasn't a system for all this, it would be an absolute mess. Well, that elegant solution, it's called a database.
And really, at its core, a database is, well, it's pretty much a giant, super organized digital filing cabinet. That's the best way to picture it. Its whole job is to store information without making a mess. Avoiding duplicates and making sure you can pull out exactly what you're looking for, right when you need it. It's all about being fast and reliable.
All right, so here's the plan. First, we'll nail down what a database actually is. Then we'll check out the different ways you can organize one. After that, we'll learn the special language they use. And finally, we'll see some of those commands in action. Okay, let's start with the absolute basics. What is this digital filing cabinet? And maybe more importantly, who's the one keeping it all tidy?
So you've got the database, right? That's the cabinet. But the real brain of the operation is the software that runs it, the Database Management System, or DBMS. Think of it like the ultimate librarian. It's not just putting books on shelves. It's handling security, checking for errors, and figuring out the absolute quickest path to find one tiny piece of information among maybe billions. And yeah, those names you might have heard, MySQL, PostgreSQL, SQL Server, those are all examples of these powerful DBMS librarians.
All right, so we've got our cabinet and our librarian. Now we have to decide how to organize the files. And this is a huge decision in the database world. It basically boils down to two different ways of thinking.
So here they are, the two main philosophies. On one side, you have relational databases. Just think of a super strict Excel sheet. Everything has its place in neat rows and columns. This rigid structure is amazing for what's called data integrity. It guarantees that, say, an order is always linked to the right customer, no mix-ups. Then you've got the other side. No SQL. It literally stands for not only SQL. These guys are all about flexibility and incredible speed. They're perfect for handling just a massive amount of messy, unstructured data. Think about all the different kinds of posts and comments on a social media feed.
And here's the thing. No SQL isn't just one single category. It's more like a whole family of different tools for different jobs. You've got key value stores, which are basically simple two-column dictionaries. You've got document databases that use flexible files, perfect for things like user profiles where everyone's info might be a little different. Then there are column-oriented databases, which are built for one thing, lightning-fast analysis on huge amounts of data. And graph databases? Well, just like the name says, they're all about connecting the dots, figuring out relationships, like how a social network can instantly show you friends of a friend.
Now, even though NoSQL is super powerful for certain things, the bread and butter of most apps is still that classic relational model. So let's focus on that. How do we actually talk to these databases? How do we ask that librarian to go find something for us? Well, we use a special language, and it's called SQL.
And the real magic of SQL is that it's what's called a declarative language. Okay, what does that mean? It means you don't tell the database how to do something step by step. You just tell it what you want. It's like you're just saying, hey, get me the names of all the customers in California. And the DBMS, our trusty librarian, goes and figures out the best, fastest way to do it all by itself. You know, it's kind of like how people speak English in different parts of the world. The core language is the same, but there are different dialects. SQL is exactly like that. Depending on which database system you're using, there are going to be these little variations in the language.
Take a look at this. Let's say you just want to get the first 10 items from a list. Simple, right? Well, if you're using MySQL or SQLite, which are super common for websites and apps, you use the word limit. But if you're on Microsoft's system, you use the word top. And Oracle's version, it uses something totally different again. See, same task, just a slightly different accent, depending on who you're talking to.
Okay, enough with the theory. Let's get our hands dirty and see what this stuff actually looks like.
We're going to build our digital filing cabinet from scratch and then start putting some files into it.
So SQL commands really break down into two main types. First up is DDL, that's data definition language. This is your construction crew. You use these commands to build the actual structure, the tables, the columns, basically the empty filing cabinet. Then you have DML, data manipulation language. This is what you use to actually work with the files inside the cabinet, putting them in, taking them out, changing them, all that good stuff.
And you always start with DDL. It just makes sense, right? You can't put files in a cabinet that doesn't exist yet. So first we use a DDL command to build the table itself, give it a name, and create all the labeled slots, the columns, for every bit of info we want to store.
And here it is in action. The command create table, well, it does exactly what it sounds like. We're creating a table called users, and we're telling it we need 3 columns, an ID, a name, and an age. Now that primary key part is super important. That's our instruction that every single ID number has to be unique. It's like a serial number for each record. It guarantees we'll never have duplicates and can always find the exact user we're looking for. And just like that, our cabinet drawer is built. Okay, this structure is ready to go. Now it's time to switch over to DML and start filling it up with actual information, one file or one record at a time. To do that, we use a command called insert into. We just tell it which table to use, name the columns we're filling, and then the values part gives it the actual data. So here we're adding ID number 1 for Anna Kiss, who is 30. Boom, our first record is officially filed. And get this, every time you sign up for a new service or upload a photo or even add something to your online cart, a command that looks almost exactly like this is running somewhere behind the scenes. And really, that's the big secret, isn't it? Every complex app, every website, every system you interact with, from your social feed to huge global financial systems, they all boil down to this one simple idea. First, you build a structure. And second, you use a clear, simple language to ask it questions. Now you know the basics of that language. The only question left is, what are you going to ask?